In the video that follows, you'll learn the right approach to refactor legacy Android applications. By the end of the video, you'll learn a lot of tips and tricks and the right way to introduce test harness that will allow you to refactor the code if you need to, with great confidence that you are not breaking any functionality that was already there. For context, this video is recorded inside a class as part of my mentorship program that you can find more information about in the link below. Now check out the video and I hope you're gonna find this useful. Enjoy! In this video, we will see how we are going to approach what we consider legacy code. According to Michael Feathers, legacy code is any code that doesn't have tests. So we have a great repository here that is created as an open source repository for training purposes, but it's not very different from any other regular repository that you would contribute maybe to, like any regular project. And the idea is that we are going to figure out how we are going to introduce tests, or let's say, regardless if you want to refactor or introduce tests without the need of refactoring, you are going to introduce what we call test harness, meaning you are going to cover the code with tests and then you are free to refactor because you have indicators for the functionality that you care about. So if you end up changing something or breaking something in that functionality, you will have an indicator in the form of a failing test for that change that you have made unintentionally. The first thing, and you should always keep that in mind, because you have code versioning tool like Git, for example, you shouldn't dare changing anything because you can at any point of time revert whatever you want. On top of that, you can create a branch and then make incremental small commits with the changes. So if you do something that you are proud of or you think it's going to be okay and you want to save it, you can just make a commit. It's a checkpoint. You can easily delete rather than, having too many changes uncommitted, and then it's going to be much harder. So you can keep that in mind while working on these kind of things. It's always helpful. What I'm going to do now, because I don't want to introduce changes in a main branch, I'm going to just create a new branch here, introduce tests for test harness. So now first I'm gonna say build and run the project. So because I'm in a branch, as I said, I'm free to change whatever I want. Because I can easily, I don't have to merge this. So I can just play around to figure out what the code does, how I'm going to approach it, like what are the different things I can do. And then once I have cleaner understanding of what's going around, then I can approach editing the code. Now back to the code. Let's first run the code. I ran it once. Let's run it once again so that we can understand what we've got here. So we've got a screen that lists some Pokemons. I think it has an endless list, so you can scroll, and then it has pagination, and then you have some detail. So far so good. So I don't know if there are any other things, but let's start from this list. Let's explore a little bit. So we got some data here, then we have domain, and we have presentation. So pretty much standard, like data, domain, and presentation. And here we have Pokemon list. So if we consider having a screen where this is being used, or I am assuming it is used in a screen somewhere. Yeah, as I thought. So we are having here some sort of navigation going on. We have a composable that describes that destination, which is Pokemon list. The state is being collected and then just passed down. Basically, this could have been done inside this, like no need to have the view model here. We can just do this call in here and do the collection here. Anyway, what I wanted to start with is we have a screen that uses the view model, right? From the investigation that I've done so far in the last 5-10 minutes, I realized that's the key. So what I can actually start now or approach this is from the view model, because the view model is clearly having some state. It is being observed in the UI. I can basically focus on that view model and see how am I about to start introducing test harness about this view model. So this is the view model. From the first glance, it just takes one dependency. It is a view model. My default state is Pokemon list UI state, which consists of some primitives and this UI text on event. It has fetch Pokemons here, then some mapping, and then load more Pokemons, which seems like a little bit of a duplication. Before I start changing this code, the idea is that I capture what it does. So I'll find where it is, and I'm gonna go ahead and start writing tests. So it is in my presentation, Pokemon list. Do I have that? There is already a test for that. So one way is to start, keep editing this test, or introduce completely new. For the sake of this recording, let's maybe ignore what is here and let's pretend that there is nothing, and then create new one. So here I'm gonna say, because this is Pokemon list, let's call this load Pokemon list test. So one difference between what we've got and what I'm actually doing here is, if you take a look here, it says Pokemon list view model test. It actually couples this test with something that is called view model, or an actual type, meaning that maybe in the future we are gonna have tests that are testing a class, or sort of dedicated to a class. That's not what we want here. What we want is have a test that tests functionality. In this case, load Pokemon list. So I assume from what I observed here, let's actually split it that way. It's going to be easier for us. I can see here in this code on the right-hand side that we are fetching Pokemons. We are loading Pokemon. So I can call this either a load Pokemon or fetch Pokemon list, and then I can start with my first test. So first, what I want to do is I want to have a runnable test to make sure that the tests are running and see, then I can refactor, I can change it. So like here, it's going to be just run. So what's my assertion going to be? I don't have this library, I think. In my live templates, I have this set. So let's maybe see what we've got. Import, is there Jupyter? Yeah, so probably we have JUnit 5. I don't know, result. Because this is the way this view model delivers results or state to the screen is through this state value, and that's basically a public thingy that has some sort of side effect. So here there are two things, like the state is the output of the system. So let's imagine that the Pokemon list view model is something like a structure that has input and output. So the input being this on event, so on event something happens, and the output is the state. So if you consider input output, basically I can work with these two. Everything else is pretty much private here. And because I couldn't or I don't want to change too much here before I feel confident changing, I can leverage those two. I can say view model state value, let's say that's gonna be my result. And if I take a look here, by default is Pokemon list UI state. In fact, I can directly say, let's see actually this API, what is expected. So expected is first. So expected would be Pokemon list UI state to be my view model state value. And that would happen before I do any events. So without doing any action, that's the default. And then I just have to construct the Pokemon list view model. So then I have to say val view model is gonna be Pokemon list view model, and then it takes get Pokemon list use case. I will just say use case, create local variable for it, and that it is get Pokemon list use case. What does it take? It takes repository, and then I'll create local repository. And then this one would be, so let me see. So we have Pokemon repository. This is an interface. Okay, pretty expected. And we have, okay, cool. So we have already fake Pokemon repository that takes in list and it returns something from that list. Let's vote here. Would you want me to reuse this one or create something from scratch, pretending that it wasn't there? Okay, so let's create something from scratch then. So let's undo whatever I've done here, fake Pokemon repository. So here it would be fake repository, and then I'm just gonna introduce it here. Class fake repository from Pokemon repository. Implement, boom, no implementation whatsoever. So far, so good. It's a time that I can actually rename this. So let's run. So it says test not found. Why? Because I'm using JUnit Jupyter, and I assume we have to do some setup in the build.gradle. So what has to happen is that here in Android, we have to tell which runner to use for the test. When we're using JUnit 5, it is important to set up the which runner to be used. And then here we could say something like test options, unit test. And inside we will see, we can do something like is return default values true. This is good for example, if you, let's say somewhere in your test, you touch on something that is Android API, let's say URI, for example, it's gonna give you some defaults instead of throwing an exception. Then for all the tests use JUnit platform. That's going to be the platform. That's going to be the runner that we are going to be using. Think now and run again. And now it passes. Now, what I have here is running tests. So I'm still not sure if this test is basically serving the purpose. I don't know just yet. And I'll tell you why. But for now, it runs. I have a confidence that the tests are running. So let me actually make a commit for this. And I'm going to say the unit tests set up and running. Why? Because like I'm expecting this to be the value, and I'm not making any calls, so just the wiring. So this test allows me or helps me to understand what's the wiring of the view model and how far I can go. And then beyond this repository, I have, let me see, implementation that talks to Cater data source. And Cater data source is something that I can actually focus on with testing later on. So what I'm trying to say here is this. The Pokemon repository is the first boundary, the first interface that my API is communicating with. So from the test perspective here, what I've got is I have a ViewModel. It talks to a use case, so both of them are real classes, and then I come to an interface. So this Pokemon use case talks to an interface. When that's the case, that's just enough. Like especially when you're introducing test harness, that's just enough of a setup to actually cover. And then the rest from this interface. So any implementation of this interface that is talking to the rest of the system, I'm gonna write tests for that implementation onwards. How do I know if this test is really working? So there is one technique that is called defect injection. Here I can say some of these properties. Let's say should load more or loading. By default is true. I'm gonna say false and run, and it should fail. And if it fails, it tells me that okay, I'm having a test that actually does catch the initial state. Now, additionally, what I can do is I don't know what this test, which lines are being checked, and the way to do that actually is by using test coverage. So I'm gonna run with test coverage, and why this is important. Test coverage oftentimes at teams is being used for checking quality. So they're saying like if the coverage is over X%, then we are good to go. Meaning that you may have 0 assertions and the test coverage is not gonna change at all. So if I run it again with test coverage, the coverage is still gonna work just fine. As you can see, the coverage didn't change and I have 0 assertions. That's why test coverage, like as a number, makes 0 sense, but the test coverage tool, when refactoring legacy code, is key, and we are gonna see why. So when you are using test coverage as a number to assure quality, it's a lost game basically, because as we saw, I can comment out all my assertions and the test coverage is still gonna be that percent. So let's say you have test coverage and it says 80%. You can go ahead and comment out all assertions, run the coverage tool, it's gonna stay 80% because the coverage is not taking into consideration the assertions. It just says this code here, like this line, is being executed in a test. That's what it says. However, the test coverage tool is very important when refactoring code because it can help you indicate which lines are being executed and with which parameters. You can check whether enough variety of parameters are being passed. So let me maybe run this entire test with coverage. Let me also take a look in the here. I want to replace active suits with new ones. Every time I run, I want to see what the results are. I don't want it to collect. I want just like single run to show me the coverage of that single run. Apply. Okay, good. So here is the thing. Here on Android Studio, we can check here on the left hand side these lines, and we can even change the color to make it more bright. It shows which lines are being penetrated and which lines are not. And the red ones, I think, which is more important, I'll make it more sort of red, bloody red, and that should help us. You see, all this code is not being, I'm not saying like if I, for example, if this code is penetrated, doesn't mean it is like very covered. We have to do this defect injection on the way to make sure that the test that we are writing actually not only cover the lines, but cover the functionality that we're trying to test. Now we can move on. We can write another test. What's going to be the next one? It would be this fetch Pokemons first. I see is not being tested. So basically I'm not collecting this state. If I collect, when I actually do collect, on start is going to be called. So how do we do that? Let's maybe write one more test. And then here we will say a load initial Pokemons load. Pokemon load. Beware that anytime we can just change that name, doesn't matter. Again, I couldn't assert that, but what can I assert is basically because we are having now state, fetch Pokemons, initial state is this, then what's gonna happen when I fetch Pokemons is that it's gonna change the state and then probably an error. So let's go one by one. So here I'm gonna have delivered states is gonna be list of, first I'm gonna have Pokemon list UI state, and then I'm gonna have Pokemon list UI state. Yeah, loading equals true. Although loading is true and by default anyway, right? I think so. Yeah, it is loading by default. And then loading message is gonna be loading message. Let's maybe move this into like that. UI text, static text, r string loading Pokemon. I think any would do. Yeah. Those are the tests that are going to be delivered, or partly, so probably one more will be delivered. So here on each it's success, probably it will be an error or something because my fake here does not return anything, and then an error will happen here, and then that error will be error map, and then this map would be yeah, let's see actually. Let's keep these two first, and then I'm gonna assert what's gonna be my expected, so delivered, and I'll rename this to the delivered states, actual delivered states. Now, what is the actual delivered state? Now, when you are writing the test like this, when you're refactoring, maybe the test, like that thingy that you're writing in the test might become big. Do not fear that. Just it is expected. It is fine. You're going to refactor on the way as you go. And especially here, because we are testing states, you have to actually create that list, and it is a little bit of code. Don't worry about it too much, just at the beginning. What's going to be the actual delivered state? So the actual delivered state is going to be, I have to collect a flow, basically. And this is a state flow. So the way I'm going to collect this, I'm going to use ternary operation to collection. So I'll do something like mutable list of this thingy, and then I'll have to collect here the ViewModel state collect. I'll do that, but first let me initiate the ViewModel. So I'm gonna say, well, I'll just borrow this thingy, and then here I would say ViewModel to collection, and then this is gonna be the actual. So what this should happen here, it should create an empty one, and then toCollection should insert all the collection, like all the events, into that one, and then I can make comparison between what was collected and what I'm expecting. It should be clear, I guess, or I hope it is clear. But because this is a suspending call, I couldn't really do that. I have to make a run test here that allows me to, it gives me coroutine scope, and then I can run this thingy. But I think this is gonna end up into forever running thingy. Let's see. Yeah. So basically I have to stop the collection at some point. So the way I'm gonna do that is I will introduce here a job. I'm gonna launch, and I'm gonna use here unconfined or dispatchers unconfined. So I'm gonna launch a coroutine, and then inside this coroutine, I am going to collect this flow. And in fact, what I'm gonna do is, instead of collecting it this way, I'm gonna say collect item, and I'll say actual add item, but I also want to print it so that I can see if there is a inconsistency. Although the test itself should tell me, by the way. And now when I'm done collecting, I can cancel the job. Now let's run and see what happens. Okay, so initial Pokemon load fails. Why? So current Pokemon list UI state. So it is 1. It says expected is 2, basically the second one, but it never happens. Why? Because there is an exception thrown somewhere, I guess. Not implemented, yes. There is 2 things. First, if I run this with coverage, it's gonna tell me that that line is penetrated, but the test is failing. So where was it? Yeah, run with coverage. So this line should, yeah, it is marked now green. The test fails, and now what am I going to do? I am going to return here. Well, result is gonna be result success, and then data will be empty list. You know, this is just the beginning. Bear with me. On the way to go, I'm gonna just add different things here, but for the beginning, let me just get a success. So I should say return flow emit result, and then let's inline this. Okay, let's run the test. Now it fails. It says expected actual is still 1. So what I'm gonna do is, here I'm gonna extend this. I'm gonna write an extension that's gonna be helping me to align the threads, the thread that runs the tests and the actual these coroutines here that I am having. So it should be maybe here better. So it's not gonna be into a specific package. So here, let me create a class, and I'll name this coroutine test extension. It should be class. It should extend before all callback and also after all callback. Let me see, implement coroutine. Yeah. So here what I'm gonna say is, hopefully you have that library injected. So I'll say dispatchers set main unconfined as dispatcher, or dispatchers unconfined. And then here I would say dispatchers reset main. And then I'm gonna mark this and this. And then I'll take this class, and here I'll say extend. So import. This way what I'm doing is, this is similar in JUnit 5. This is similar to what rules are in JUnit 4. This will run once before all tests, and it will run once after all tests. You can, of course, you can make it run before each test. So instead of before all, you can extend before each. The thing is, it gives you like an API. It gives you a callback. What do you want to happen before all the tests are run? For this particular implementation, coroutine test extension, it's just a class that extends those two and it overrides the functions. What's going to happen is that before all the tests are run, it's going to replace the main dispatcher with unconfined. And then after all the tests are run, it's going to reset the main dispatcher back to normal. For this, what it means when this Pokemon list view model is being run from the test, when you say here, anywhere in this code, when you say ViewModel scope, like this one, this ViewModel scope internally, if you take a look, is using dispatcher's main immediate. But dispatcher's main is not available in the tests. So we want to use the same dispatcher for the tests. We want to use the same dispatcher that we are actually using in the tests. So we want the main or the one of the ViewModel scope that this class will be using to be the same dispatcher that we are having in the tests. When it's the same dispatcher, the results are okay. We want to inline them. So when the test is being run, this Pokemon list view model, it will try to use some coroutine scope. When it uses this view model scope, for example, there is some coroutine dispatcher inside, and that dispatcher, we are actually setting it to be unconfined, and this is the way to do that.
Okay.
And then when I run this test, and I'm using here also unconfined, it will be correct. Let me run. Yeah, now we've got the both emissions. So now it works fine, but it's just like we have difference in the expected stuff. So let's see what is different. Then here we have the first emission is loading message null. And then we have here loading message null. Should load more false, should load more false. Load message null, loading through, Pokemon's empty list, error message null. Great. The second, as we can see here, the actual is loading message null, should load more false, basically the same. Oh, I think I know what's the difference. The difference is in the Pokemon list UI state loading message. In the message, the instance is different. The instance of the sealed UI, this is not data class, this is just a class static text. And that's the problem. So it doesn't know. So if I make this data class, I'm gonna remove the unused import, run the test, primary constructor, what? Okay, so it doesn't like var args in a data class. What if I make a list? Okay, now it works, but there is still something mismatching. Let's find out what. Loading message UI text loading Pokemon args nothing empty. Should load more false. Is should load more false by default? Oh, loading equals false. And then Pokemon's is empty. And error message now. Is that what it wants? Yes. And now if I run with coverage, so it calls this, which actually sets first loading to true and loading message. And then it has success, Pokemon's data. And then it does on completion, which sets the loading to false. Okay. More or less makes sense. Now what I want to do is, well, let me actually commit this first. Cool. And now what I would do is I want to extract this into an extension function so I can, it's going to be easier for me to perform testing. So I can do something like function collect flow. So state flow, I will make it generic. And then it will return list of the collection. Then inside I'm gonna get this, and I'll return the collected where is it? Actual delivered states, but instead it will be T here. Then here I'm gonna say coroutine scope collect. So I'm gonna have an extension on a coroutine scope basically. So I can collect this anywhere I have a coroutine scope. I'll have to pass the flow. So this would be the state flow collect. And I can also take this if I want to do sort of more control. Dispatcher, coroutine dispatcher. That's gonna be defaulted to dispatchers unconfined. Then we've got item. Okay, so this looks good to me. I can extract this into, let's say, a file of its own. But let me replace this here. So what I'm gonna say is this is going to be collect flow ViewModel state. And that should still run. And now I can take this, put it into, let's say here, coroutine extensions. Okay, cool. So I just have to import this. Okay, now what I would do is, I'm gonna make a commit of this and push it. And then we can continue next, not tomorrow. Tomorrow we have a co-working session on Thursday, because we are nowhere near done, but there is a bunch of other things that we can do. But let alone being over time, my wife is calling from the back because she also has a course going on. So I'll have to handle the kids. So let me do here extract an extension function for testing. And then I'm going to push this branch just in case. And then we can proceed with the rest of the code. So for example, how the mapping will work, what happens when I have some results, like now the list is empty, when I have more, what if I want to introduce page, how that's gonna work, what if I have, for example, error. So all those cases. So we're gonna cover the whole thing, and then we can start the refactoring. So probably there is a bunch of things that we can improve here, remove this duplication, and then work one layer at a time. Then we can go to the use case, see if we can refactor something, and so on and so forth. Anyway, now we see that all these lines that are green here are being penetrated. It doesn't mean that they are tested. It doesn't mean that the whatever this line produces as a result is being covered. It just means that it is penetrated. If I just, for example, comment out this line and run the tests, I should have a failing test, right? So that is one example of defect injection. Now we can proceed further to cover these other lines of code. So for example, here, what we do, the state, initially when we start collecting, it calls fetch Pokemons. The fetch Pokemons function invokes the use case. It has again on start as well to update the UI state. Then on each emission from the use case, on success, it updates the state. But what happens on error, we haven't gotten any result just yet. So let's cover maybe that case. So I'm going to start off with a new test here. I will name, let me close this, initial Pokemon load, Pokemon loading failure. I'm going to call this. Now I am going to borrow this, and then the expected delivered states are going to be initial one. That's how we start. And then we need to get to the error. The error is going to be, so the loading will be false, which is on completion, but the error is map error to UI state. And we get to this function, map data error to UI text. If the data error network is unknown exception, it's going to be unknown error. We can try that actually. So we have to cause or get from the fake repository when we make a call for that test, we need to get unknown exception. And that unknown exception should create this error. So in that sense, here we are going to have UI text, static text, R string, unknown error. Let me clean up code. And that would be our expected states. What are the actual ones? The actual ones are going to be, we are going to collect a flow, and this flow is the ViewModel state. What's the ViewModel? What's the state? What is collect flow? We are having compilation issue. The collect flow is an extension function on a coroutine scope, and to get one, we can say here run test. That gives us a coroutine scope, but it asks us to have a flow. What's the flow? We can borrow the setup from here once again. However, right now, the fake repository returns success no matter what. How can we control that? We can pass here an argument. So you can say set, like you can do apply, set is unavailable. So it's gonna come with an unknown exception. So this function, we can create it here. In fact, if I Alt Enter, it will create extension function, create member function. I need a member function, set is unavailable. I can keep this is unavailable in a property, in a variable simply. So I can say is unavailable equals true. And then here I would keep a private var is unavailable. That's gonna be false by default. Oops, it should go above the function. And now when I try to get Pokemon list, which is what the use case does, like here, if we go to the use case, invoke calls get Pokemon list. So far, so good. So here I would say if is unavailable, I'm gonna return flow emit result error, and that one would be data error network unknown exception. Otherwise, it's gonna proceed with the rest as it used to be. So let me first run with coverage so that I can see if this error is being, yeah, so it's covered, but something wrong is going on. And what's going on is, so first state, we can see here, we are printing the state. The first one is loading message null, should load more false, load more message loading true. So basically this is null, false, null, true, empty list, and null. So that's fine. Then the second one, so this should be error message instead of loading message. But it seems like also the loading message is UI text, static text, loading Pokemon. I think this one is not being reset. Yes, correct. So what happens? So you see, we have figured out a bug right now, because like this loading message is not being reset when the flow is completed, when the whole call is completed. So what happens is, like on the start, it sets show loading, like this loading message, it sets a value and it sets the loading to true. And on completion, it only resets back the loading false. Here it should also reset the loading message, basically. So I'm gonna add here a comment, probably also reset back the loading message to null. Cool. Let me run once again. I really love when the tests are passing. Yeah, that feeling, that dopamine, it's awesome. Now what I'm gonna do is I'll commit this. And now, to make sure that this is all covered, we can try injecting some errors. So for example, if I comment out this line, is it going to cause a test to fail or not? I don't think so. Yeah, it's not. So how do we cover this one? So we have to write one more test, and that is usually when, like before you start refactoring some code, you have to introduce test harness to make sure that everything is being covered. And this is one way to do that. So if I, for example, comment out this line, so we can go top to bottom and comment out some lines to see if we are catching it. So this one is we are catching. What about this? This one is basically unnecessary because by default, the Pokemon list is true, loading is true.
Oh.
So setting it here once again doesn't really change anything. So that's fine. So how do we cover this? How do we cover this is, here we have initial Pokemon load. I'm gonna rename this to load, well, Pokemon's list is empty, or Pokemon list, yeah, is empty. Let me commit this, update naming for clearance. Then I am going to create one more test. It is not a good practice to copy paste the tests. I'm doing that here for the sake of the time, but I'm gonna go through each and every line. So Pokemon list loaded. Then a fake repository here, I'm going to pass some Pokemons that are gonna be returned. So Pokemon list is all Pokemons. And now, what is all Pokemons? What is Pokemon list? Basically, this one will take Pokemon list, which is going to be a list of Pokemon by default empty. And now, instead of this data being empty list of Pokemon, it could be Pokemon list, and then I can inline this so that it replaces everywhere. Now if I run, oops, yeah, all Pokemons, what does it do? It should be, the way I am practicing this usually is, I would create the variable as close to its usage as possible, then I'm gonna extract it for usability. So here I'm gonna create all Pokemon is gonna be list of, let's say, Pikachu. And does somebody knows some other Pokemon? I don't know the names of the Pokemons. So here would be Sparrow. Nice. Now, what is this? This is gonna be local variable. This is gonna be Pokemon. And then this one is Pikachu. Now, the other one's gonna be Sparrow. Cool. And now here, then we are going to have loading message, but also Pokemon is gonna be list of Pikachu, Sparrow. That's what we are gonna have an expectation. Let's run the tests. Oops, it is not running the tests. It is running the application, the last run. There we go. Now, if I comment out this line, run, boom. Now we have covered. And let me then commit this. So now what I want to do is I want to extract a little bit these things. So I'm going to extract them here, and I'll make them all private. And then I will take them and move them in the top of the test. And then inside the test, I just use the abstractions, which makes it a bit more like easy to understand. So Pokemon is gonna be then all Pokemons. So then we have this symmetry here. I'm very, very, how to say, picky about this, or very careful, so that if I see in the test, given I have a repository that has Pokemon list all Pokemons, I am asserting that those Pokemons are returned. So I'm giving this, it should be here in the expected results. So that makes the intention of a test cleaner. That makes the test understandable. And when somebody reads this, okay, I have a repository that has a Pokemon that is being used in a use case, then the use case being used in a view model. I'm trying to collect a flow that probably causes something, and then the delivered results are gonna be initial one, then the one with the Pokemon. It makes the test cleaner. It's not that like if you write it in a different way, it's not gonna be as valuable, but having it as clean is gonna be much easier for whoever comes to the project to see, and they're gonna say, ah, cool, like now I see why, for example, this result is where it is coming from. I wanted to also introduce different asserting library so that we can have assert that expected delivered states, like assert that actual delivered states is equal to, and then we can have this. I think that way is making it a little bit cleaner, but never mind, we can stick to what he has before. So let me run the tests, they should work. Yeah. Okay, so where do we get to? We get to here. So what if I comment out this line? Oops, I couldn't comment out, but I can. What is this? This is UI text, static text. What if I do here? Oh, I have to also cover these other things. But let's say that here I'm going to say static text 0. Okay, that's at least covered. But how can I, like, what else I can do? I can copy this guy. I can paste it here and run. And I have a failure. That's good. Put it back. It works. State copy. Error message. Works fine. And then on completion, we tried that. So what we can do now, we can say confidently that all this that is covered is basically we have coverage for the tests, except maybe for these cases, which are the errors. We can do additional tests. We need one more, like 1, 2, 3, 4 more tests to cover the actual errors, the correct ones. Where was it? Here. So copy of this test. And the approach I usually take is I want to cover everything before I approach changing any code. Although this is pretty isolated function that can start changing, I'm not gonna start doing that. I would keep writing tests until I cover everything that I believe should be covered. Another technique that I wanted to show, if, for example, this one was, let's imagine that Pokemon here has 30 properties. Now it has only two, detail URL and name. What if it had, let's say, 10 properties? Then in a test like this one, it would be very hard to create an instance of it, especially if you want to create multiple of them. So a technique that I use is extracting builders for the tests that we can also use in production if you want to, but usually, I mean, we rarely have a need for that. Yeah, so how I would do this, basically, wherever I have the Pokemon, so the Pokemon is, let's say in presentation Pokemon, Pokemon is inside com Anthony Pokemon domain model. So here in the domain model, I'm going to have Pokemon builder class. Then I would take the properties.
Like how many variables we need to have to do this?
Yeah, like when it becomes annoying, I would say. So for this, for two, it really doesn't make sense.
Yeah.
For two, but I just wanted to show just because Uduak said let's take a look into it.
Yeah.
And then here I would usually, what I do is I take these names, then I create functions. Here I would say function with that name, take that name in, is gonna be apply. This thingy is thingy, and then I'll update the names with proper camel case. And then here I will create a build function that will return the thingy. And I can directly say equals Pokemon name data detail URL, like that. So far so cool. And then I can just create a companion object that will create a function a Pokemon that will return back my Pokemon builder. And in my test, what I can do is here, instead of Pokemon Pikachu null being default in the builder, and I only want to work with the name, I can say here a Pokemon with name this build. And then we'll repeat the same here. Build. Of course, we can make a DSL for this if we want to, but like, yeah, up to you. I do like this syntax. So then I have a Pokemon with name Pikachu, a Pokemon with name Sparrow, build both. Yeah. Then I have all Pokemons for convenience, and then that's it. So let's commit these two. So now we have the code as well on the repository. We are going to proceed in the next call. Or one of the next calls when the time permits. That was the first part of our refactoring session where we were introducing test harness, and at this point we can freely change the code with the confidence that we are not going to break any functionality that was supposed to be there, because now we have indicators in a form of failing test if we happen to change some behavior unintentionally. Let me know in the comments below if you want to see the following of this video where we are actually going to approach changing the code and how that's going to be done. Thanks for watching, and I'll see you in the next video. Cheers!